Now, the rules regarding the first principle that I want you to know is that, let me try and clean this up. First rule in solving first principle is that this is a function. When you are given a function like this, y equals to x cubed plus 2x squared. First thing that comes to your mind is that add the y to the y side. That is the first rule. Add the x to the x side. Wherever you are seeing x, you will adding the differentiation of x to that x. Then add differentiation of y to that y. That is the first rule. Are we good to go? Then the second rule, please try and be jotting something down. The second rule is that make use of what? Make use of, after doing that, try and expatiate it. That is the second rule. Then the third rule is that when we are solving it, you will know more about what I'm saying. Just try and just be noting it down. The third rule guiding this is that to the other side, bring the value of y. You know it is the y that we are looking for. And when I add the y to this y, then this y must go. First, it is the y I want to make the subject of the formula, not y. I'll bring the y to the other side. That is the what? That is the third rule. Bringing it to the other side, then substitute in the parameters for the y. What y equals to. I will tell you that when we get to that. Then expand it. That is the fourth rule. Another one, I will be breaking this. I'm just summarizing it. When we are doing this, you will know more about it. Then the third one, after the fifth one, after expanding, the fifth one here is that divide through by the dx. Because we need dy dx. Not only dy, we need dx. Divide through by what? Dx. Then the last one, limit the x to be 0. If there is still additional dx inside this particular function, you have to limit it to be what? 0. All this particular side here, there must not be dx there. You have to limit it to be 0. When I say limit it, when we have dx there, whenever we see dx there, you are going to put 0. Limit dx to be 0. We are going to be putting what? 0 inside. Are we good to go? With this key principle, with these key rules, we are good to go. Now let me be implementing these rules. This is the question. Now I said the first rule said add the y to the y side, add the x to the what? The x side. Well, now let's put that. The y plus we have y here equals to. Now what for? We have x here. What am I going to add? I will add the x. X is having keep here. Keep that aside. Just say x plus the x. Put it in the bracket. Then put the cube like that. Put it on top. Now the next thing to do is plus. What are we having? We have 2 here. What join this and it is times. You open the bracket as well. This is x. I will add what to it? The x, right? Plus the x is having square on top. Put square here. I will go to go. So after getting to this particular junction, then you can make this equation 1. Then the next thing to do here, I will together try and mix and expand these brackets. Expand this what? Brackets. You can expand these brackets in different ways. You can either use a Pascal triangle under binomial theory, normal mathematics, to expand this, or you use factorization to expand this. Anyhow you do. If you use a Pascal triangle to what? Pascal triangle to expand this. Pascal triangle to expand this, you are going to go. Then if you also use a what? A factorization method to expand this, you are also going to do. What do we use here? Should we use a Pascal triangle? Or should we use the factorization? Anyhow you do. We should make use of the Pascal triangle, right? Now, the Pascal triangle said, when you are using a Pascal triangle, say, what are you having here? You are having 3 here. The first thing to do, Pascal triangle stands for the art of expanding without using, when it is more than 2, without using s plus the x in another bracket, s plus the s in another bracket, s plus the s. You know, it's somehow bulky, isn't it? It is bulky. For you to start saying s times this, s times this, s times this, that is excess of using Pascal or triangle. It can reduce the expansion. That is excess of using Pascal triangle. It's shortening your time. It gives room for what? Time factors. Are we? Now let's make use of the what? Pascal triangle. Now, you know, normally we have to expand this in 3 times. You can do it like that. But because of the time frame in the exam, you can quickly put this inside Pascal triangle and you get whatever you want to get. Are we? Should we to do that? Now, all the thing that you cram here is that you know when our n, I told you that this is n, right from the general principle. When n is 0, what would that be? No, just cram this. Since it is 3, there will be another day to explain what a Pascal triangle is. But just try and know this. Let's use what we want to use there. When n is 0, are we together?